Right. So let's start real easy. Let's start real easy. Differentiate this statement of this. Differentiate 2x squared. That'll be 4x, right? Bring down the power, and minus 1 on power. That's simple, right? So we need to be able to see where that came from, right? So we need to apply something called first principles. Within first principles, we're going to apply the limit rules that we learned last week, right? Or big before. All right. So I want to show you now how we really got from here to here by using limits, right? So for example, dy dx, oh, by the way, f of x is equal to 2x squared, right? So how do we find dy dx? dy dx is equal to the limit as h approaches 0 of f of x plus h. There's f of x, right? So what would f of x plus h be? Where we have x, you put in plus h minus 2x squared. This f of x plus h is f of x. That's okay? All over h. The objective is to simplify it out and then drop in h. Right? So let's expand that out. Let's see what will happen. Let's expand this out. You'll get 2 by x squared plus 2xh plus h squared minus 2x squared all over h. When I multiply numerator out, right? When I multiply the numerator out, right? When I multiply numerator out, I'll get the limit. Please don't leave out these things, huh? It's a limit question, so you can't just simplify it and leave this out. You have to leave the limit there all the time. You'll end up with 2x squared plus 4xh plus 2h squared minus 2x squared all over h. What does normally happen if you do this properly? The x squares normally cancel off, right? And then we can simplify the h's easy. We'll end up with the limit as h approaches 0, h into h's, that'll give you 4x, h into h squared is 2h. Are you okay with that? So h into this is 4x, h into this is 2h. Right? Now, as h approaches 0, all we have to do is plug in wherever you have h, plug in 0. So we will end up with dy dx being equal to 4x plus 0, which is 4x. That's okay? Add up. So the answer is 4x. Copy it down. It's just to show you where it comes from. So like where this came from is by using limits in between it. Copy it down. I'm gonna give you one to try. Try that fast. You're done? Right, so we end up with dy dx being equal to the limit as h approaches 0 of what? What would it be? 3 by x plus h squared plus 2 by x plus h. This is your f of x plus h. Right? Remember this f of x. So f of x plus h is everywhere you have x, you put in x plus h. That's what I did here. Everywhere I have x, I put x plus h. You sure? Nah, you're something like, right? So watch this here. This is f of x. So if I say f of 2, and you'll put 2 by 2 squared. So if I say f of x plus h, you will put f of, sorry, 2 by x plus h all squared. Same thing here. Same thing here. F of x plus h will be x plus h all squared plus 2 by x plus h. And then minus of f of x. So I write in 3x squared plus 2x all over h. Thanks, right? Right? After you finish this, right? Multiply it up, see what you get. I have 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 3x squared minus 2x. Normally the x squared will cancel. Up minus 1 plus right? Normally the x squared terms will cancel, and then we divide everything by h. Right? So we will get the limit as h approaches 0 of 6x plus 3h plus 2. You okay with that? Are you okay with us?
Yeah.
And then put each as 0 and you'll get 6x plus. Oh, yeah. Right, so the answer is 6x plus 2 here, right? You okay with that? Oh, for those who not ready to take a picture fast. Yes, you. Let's try this one, square root of x. I'll help you with this one. Let's try this one here, right? Remember, when you have this square root of short, when you have this square root, remember, Right. So this one here is different. Yeah. Right. By the way, before we work it out, right? What's the answer? What's the answer? What the answer supposed to be? It'll be 1 over 2 root x, right? That's what the answer is supposed to look like. But the problem is when you work it out, you're going to get a right, multiply by a conjugate of the numerator. So dy dx is the limit at h approaches 0 of f of x plus h, which is square root of. That's okay? Right? Now you don't do that. Right? Provided you do this next step, yes. So when you reach here now, remember, if you remember the other examples, we had to find a way to cancel off these things, but we can't do it right now, right? So when you reach here, you multiply by the conjugate of the numerator, not denominator, right? So the conjugate of this is root x plus h plus root x all over root x plus h plus root x. Okay? So you multiply this by conjugate over itself, right? What you just normally do is don't try to multiply the denominator. Just leave it like this, right? Root x plus h plus root x. The numerator, on the other hand, you multiply it, right? Keshav, you recognize this? Difference of 2 squares, right? So to multiply it out is really x plus h. Well, let me write it on the long way, right? The square root of x plus h squared, square root of x squared. When you multiply this out, you'll get this, right? And we will end up with something like this. Square root of this is x plus h, square this is x. What will happen with the x here? Right, the x will cancel, right? The x will cancel. So by doing the rationalization here, we end up with something like this. X will cancel, and you will get the limit as h approaches 0 of h over h by root x plus h plus root x. What will happen with the h's? Cancel, right? So you'll end up with 1 over this. What's the next step? Trouble? And I have coming up. And you know what I mean? Where you get lost? Follow here, they have cancelled. So you end up with h, right? And you have h by this underneath. So now the h will cancel. H into h is 1. So you'll be left with the limit as h approaches 0 of 1 over right? Don't multiply it out. Leave the h on the outside. Now, when you reach here, what's the last step? The last step is as h approaches 0, right? So as h approaches 0, you're going to get 1 over. This becomes 0. So you're going to get root x plus root x. Right? Root x plus root x is 2 root x. That's okay? Copy it down. Let's try the next one. Question? Right? You only do this if the question says by first principles. Huh? If not, you go ahead and differentiate like normal. Try that there. 2 over the square root of x. And then we're going to do a trace. Whatever do a curve rule, first principles. Right? What we're doing here can work for like a quotient rule. Right? It kind of work on quotient rule. If I give you a quotient rule and you have to apply limits. Right? Before we multiply by anything, we have to make sure and simplify top, right? So if I find the LCM here, it will be x plus h by root x. On top here, I will have 2 root x minus 2. And what will happen with this h underneath here? This h will flip up here, right? So I'll put in by h as well. I don't want to multiply it here. Right? I found the LCM here. This by this, this by this, this by this. Right? So I found the LCM there and then I flip the h up. Right? So I have this now. So now I want to simplify this a little bit. This okay, I'll leave this as it is. Right? I'm going to multiply by what? Conjugate to this, right? So I'm going to multiply by 2 root x plus 2 root x plus h all over 2 root x plus 2x plus h. Yeah. Yeah. Right? When I multiply this here, what will happen? Right? So I simplify, I got this, I multiply by the conjugate of the numerator. Right? So now I'll get the limit as h approaches 0. This by this, I'm not touching it, I'm leaving it as it is. So I'm multiplying h by this. Multiplied by this. Right, if you want to factor the 2, you can factor the 2 as well. And then we apply, we see in difference of 2 squares, so it will be 4 root x. Actually, let me write it out for you. Anybody lost? I'm starting over, right? From here, I found the LCM. From here, I found the LCM and I got this. And I take the h and I flip the h up. Right? When I reach here now, and multiply by the conjugate of the numerator. The denominator, okay, that has a product. The numerator is a problem. Because I need to simplify and get rid of that h, right? Right? This h is a problem. I have to get rid of it. Because if I leave this h here, when I put 0, the whole thing becomes 0. Right? And it becomes something undefined, right? So multiply by the conjugate of this. Right? And multiply the denominators, I get this. And I use difference of 2 squares on top. Huh? So now I have the limit as h approaches 0 of, when I expand this, I'll get 4x. When I expand this, I'll get 4 by x plus h all over. I'm multiplying this out one time, right? Actually, let me just skip no stops. What will happen on top? I'll get 4x minus 4x minus 4h, right? And the x will cancel. Yes? I'll get minus 4h on top, right? So I'll get 4x minus 4x minus 4h all over h by this long product here. Are you okay? Actually, are you okay with this? Okay, ready? I will stop then, so you'll finish, right? I will stop now. Yeah. Just in my mind. That's all. I just keep using my mind now. At my mind, right? 4x minus 4x will cancel, and then you will see the e canceling open. Adam? And then after that, what you'll do? Think it? H equals to 0. Yeah. Right? So I just cancel in here and I cancel in here. And I put in h as 0. That is when we are approaching 0, right? So I'll end up with minus 4 over, this is 0, root x by root x is x. And here h is 0. So again, 2 root x plus 2 root x is 4. 4 will cancel. So my final answer is minus 1 over x root x. All get that? Right? Take your time and simplify it, right?
Anybody else go home? Right?
Like now, when you're done, you can't do it fast yet. From here, you can take it. You don't want to do it.
So, if we get from this one,
Yes.
if we get just
I'll call parents and they can decide out. So I mean, in school? Yeah, yeah. No, they'll get some, they'll get it come now. I think I can. Who?
So you know, I'll get you good video.
Is there? I never seen it. Right, try that please. Copy it up and let's jump to the cosine. Okay. Hello? Hello. I can.
I'll see you.
Right, sorry about that. Trouble anywhere here? Ashley, trouble? Follow went on, right? Right, the X is cancelled, then the H cancelled, and I plug in H is 0. Sure. Right, let's take a look at trigs now. In the trigs, you're going to have to remember some of your rules, right? Right. We reach a point here where it gets a little bit hard, right? What did you here?
So apply double. Come on.
So apply combine expand it out, right? So we have two options. We can do that, or right. So we can apply this rule, cos A plus B, and expand it out, or we could do cos A minus cos B. Remember this rule? Factor formula. So you can also apply factor formula here as well.
So tricks is
One of these becomes. Anyone becomes.
how much months is it?
How much it was? About 4 or 5 months.
Yeah, you know.
Right? So we will end up with the limit as H approaches 0. We can expand this out. You'll get cos X, cos H, pluses minus, right? Sin X, sin H, minus cos X all over H. What you do now? What you do now, Severa? Right? Severa said bring all the cos X together. Right? All over H. Right? Ideally, when you reach here, we just split it up. Right? Put this over H and then put this over H. What can I do when I reach here now? Yeah? Factor of cos X. Right? So I could factor out cos X, and I will get cos H minus 1, and I'm bringing this over H, and I'm doing this part as well. The limit as H approaches 0 of sin X sin H over H. Right? Just follow went on here. Yeah, I split it one time. So I split this over H and this over H. Right? So I find the limit. I'm going to work out this first, and then I'm going to work out this. Right? Nathan, what can I do with this cos X? Is this cos X affected by this limit? No. So it's a constant, huh? So I can take it outside. So I'll get cos X by the limit as H approaches 0 of cos H minus 1 on H. Okay, I can do the same thing. Minus sin X by the limit as H approaches 0 sin H on H. Right? From the little handout I gave you, you remember what it says, Adam? This here. That's what?
Yeah.
This is 0. So that will be cos X by 0. This is 0. What this is? This is 1. Sin X by 1. So your final answer is minus sin X. Right? So you gotta remember all the trig rules. Okay, and the limit rules as well. Right? copy it down. Let me give you one to do, and then we move away from it. Here's a rule you have to learn. I gave you some special rules to learn for limits. This one is 1 and this one is 0.
Oh, alright.
Factory, not inside here. Not inside here. Try this one here from a please. That's not right. Our first principle here, sine 2x. Any questions online on this one? Yeah. I ain't seen it, but it was f of x is equal to sine 2x. Last one. Do that, please. Try that, please. Or then, remember, I send the link to send cash course, right? Can't put it on this week, right? Yeah. So like, I'm going to advertise doing it this evening. I'll follow up. But she said she had to go yesterday. Yeah. So I messaged in all the last week. Yeah, I'm not following my order to open it. I think it's huh? Oh, Friday. Yeah, everything is but work with. That's right. Hello. I don't think we have. Time 2x, right? Yes. You should have 6. I give it now. So how about there is good rate on line? So how you go with that sort of right? Like that because that's the question. I get about simple, right? Yes, sure. No, same limit. Same first principle. Same first principle. No, no. Oh yeah. Right, and then using the expansion for this. Figure out. Use the expansion for that, and then do the same thing here. Oh yeah, forgive me, only a few minutes again. Which one? Oh, I mean, yeah, well, yeah. Oh. Which one do you mean? Oh, yeah.
Haruki mistakes it.
Oh, you're right. You don't have to. Oh, you're right. On the outside. Is that anything possible? Right, so you have sine, remember you're using sine A plus B, right?
No, it's not. You get full marks and pass them. So now, so no, you get full marks.
Right, oh yeah, bring it together. Bring your like terms together, factor out and hurry up. Well done. So you are bringing, you're bringing your sine 2x together. So you'll get sine 2x cos 2h, right? All over h, and you're splitting it up here with the limit as h approaches 0 of sine 2h cos 2x. Oh, sorry, over h. Right? What's the next step, Anya? What's the next step? Focus on this piece here. What I can do? Take out the sine 2x, right? So I can factor out sine 2x because this limit doesn't affect the x, right? Right? So I factor out sine 2x here. How about here? Take out the cos 2x, right? And I'll get the limit as h approaches 0 of sine 2h over h. That's okay? What is this here? What's the limit of this here? This is 0 again, right? I have a slight problem here. This is sine 2h on h. The value here must be what, Adam? If here is 2h, here must also be. So to get a 2 here, what do? I multiply by 2, right? So multiply by 2, divide by 2. Right? So now this becomes 1. Sorry.
Last night I said,
Yeah.
so what? Oh, yeah, side to h. You don't know the cost to it.
I put it in front. No, it's multiplied. It's multiplied, right? So I'll pull it out in front here. Right? This value here is 1, so I'll end up with 2 cos 2x by 1. So the final answer is 2 cos 2x. Right? So you have to remember all the rules, right? So you have to remember this somewhere we did a week or 2 ago. Now let's take a look at normal differentiation, right? Or I'm getting a full question. Huh? Four questions? A question of 25 bucks. So you gotta get 2,000 people. I know. Might be a distinction, but it might be a one. Right, so let's see if we remember any rules for differentiation, huh? Right? Let's run over some rules quickly. Anybody remember chain rule? Right, chain rule is dy dx is equal to dy du multiplied by du dx. That's okay? Product rule dy dx. If it's a product, if it's y is equal to u by v, it will be u dv dx plus v du dx. Then we have our quotient rule, right? If you have it in this form, u1 v, yes. So you're going to get dy dx is equal to v du dx minus u dv dx all over v squared. Right? What does d2y dx squared mean? Huh? So you're taking dy dx and you're differentiating it again with respect to it. Right? You'll recognize that you're going to get d by d, which is t squared, and you're going to get dx by dx, which is dx squared. That's why it's written like this, right? All right, so what's here? Right, just some quick rules for you to remember. How do we differentiate? We bring down the power. We put back the a and we minus 1 for the power. Oh, right? What's the differential of cos ax plus b? Right? The differential of ax plus b is a. Differential of cos is minus sine. And then you write back ax plus b. Right? Question. Suppose you don't remember this. Which one of these rules you could use to find cos ax plus b? Chain rule, right? Chain rule let u equal to this. Right? Here, same principle, differentiate ax plus b, you'll get a, differential of sine, cos, and then write back ax plus b. Here, what's the differential of tan?
Sec squared.
Sec squared. Right? How you prove it? Tan is sine and cos and use quotient rule, right? What's the differential here? Differential of ax plus b is? Differential of tan is? Sec squared, then write back. Right. These two technically not in unit 1, but I've seen where they brought like integration and they're expected to know things like that. So I'll show you one time. Real easy. Right? How do we differentiate f of x? Take the f of x and bring it in front. Right? Sorry, take the differential of this and bring it in front. Okay? So if I gave you e to the 2x, if I gave you e to the 2x, the differential of this is simply differentiate 2x and write back e to the 2x. So the differential is f prime x e f of x. All right? Ln, real simple. All you have to do with ln is f of x is your denominator and your numerator is the differential of it. That's all. So if I gave you ln x plus 1, the differential of this, x plus 1, denominator, numerator, differential of that. Right, Chloe?
So, if you like something like x squared, we do
Same thing, differentiate the power benefit from. All right, so let's remember that rule, right? So just pay attention to these two. This one not so popular, but I've seen this in some of the integrals, right? So to integrate this, you'll get back this. So we to know the differential as well. And then tell me what was the answer here. Right, next we have the application. What's the next? We'll do the applications of differential.
yes. Yeah. Yeah.
Huh? Yeah. So we don't differentiate number 8. And let's just try one, right? But like this, but so. Right? So to differentiate this, you bring down the power, you write back the differential of this. The differential of ax plus b, and then you write back ax plus b minus 1 for the power. All right. There's some small rules to remember. All right. So I'll give you one here from 2017. We're doing the first part at least. Given that y is the square root of 2 plus 2x squared, they wanted to show that y dy dx minus 2x is 0. Right? We're just doing part 1 alone. Right? Given this, show this. Next week, we do the applications and differentiation. Right? One of the applications curve fetching. I showed you all that transformations in functions, right? So I'll show you all different ways to do it. Oh, yeah. Try that in. Show that y by dy dx minus 2x. How you differentiate this? Okay, Sharp? How you differentiate this? Okay, all right. Go ahead, I'll give you a minute to finish. Or you could use number 8, right? You could use the shortcut. Gosh, Eviana, sorry, I don't know, seen it. Number 3. And the first line, we are now seeing it perfect. You got through with it? Okay, sorry about that.
Yes.
Right, let's see what you got. So bring down the half, differentiate inside the bracket, write back the bracket, and minus 1 from the power. Half of 4x is 2x all over the square root of 2 plus 2x squared. Right? Anybody recognize this? What is the square root of 2 plus 2x squared? And that's y. So therefore, dy dx is 2x over y. Right? So if I multiply it by y, so dy dx multiplied by y minus 2x. If I plug it in here, I'll get 2x by y multiplied by y minus 2x, and you'll get 2. That's okay? And that's using the 9 marks. Sorry, that's all. That's 4 marks. All right? So next day, we'll take a look at the applications of differentiation, right? Right? Next day, we take a look at application.